We're going to start our work in trigonometry by talking about angles and angle measure. Everything that we do in trigonometry is assuming that we have an angle in the Cartesian coordinate plane in standard position. So let's talk about angle measure. Every angle has a vertex and two sides made up of two rays. The rays share a vertex. The angle has an initial side. We always place that initial side on the x-axis, and it has a terminal side. The terminal side is the side that helps us determine the measure of our angle. So we're going to take our angle and we're going to put it in the Cartesian coordinate plane. We're going to put the initial side on the x-axis with the vertex at the point of origin. And then depending on where our terminal side is, that gives us the angle measure. For instance, here is an angle, right? And then we could put our terminal side here. There would be another angle. Here, the one that's shown, here's our terminal side, and this is our angle. Well, these distances are the measure of our angle. This is how we determine the measure of our angle. And you remember from geometry, we have acute angles, we have obtuse angles, we can have a straight angle if it was laying here all the way across the x-axis. That would be the measure there, 180 degrees. So the initial side of the angle in standard position is always located on the positive x-axis with a vertex at the origin. And while it's in standard position, then we can talk about our angle measure. We can talk about positive angle measure, negative angle measure. It turns out that when we have an angle in standard position, any measurement from initial side to terminal side that happens counterclockwise gives us a positive angle measure. But it's also true that if we measure and take that terminal side in the clockwise direction, then we consider that a negative angle measure. So here is a positive angle and here is a negative angle. So whether we're going clockwise or counterclockwise from that positive x-axis determines whether we're talking about negative angle measure or positive angle measure. And we do generally show angle measure or show angle direction by an arrow. So how do we measure angles? You're very comfortable with measuring angles in degrees. So it's the amount of rotation from the initial side of that angle to the terminal side. How much ever rotation was made is the actual measure of the angle. And since Algebra 1 and geometry, you're very comfortable with measuring that in degrees. And we know that one single full rotation around anything is going to give us 360 degrees. No rotation at all, if it's just like that, the initial and terminal side are laying on one another, that's a 0 degree measure. And then when we go in this direction, we can stop at any certain point, and 1/360th of that will give us our degree measure. And it's true that we measure in degrees, and then we measured in minutes, and then we measured in seconds if we needed anything that was smaller than 1/360th of a revolution around the circle or whatever it was that we were measuring with our angle. So here are our degree measures, and these are common measures that we're used to dealing with. We know that one full rotation, just like I said a while ago, one full rotation is 360 degrees. If we make no rotation at all, again, that initial side and terminal side are together, that's 0 degrees. It is possible to have an angle measure of 0 degrees. It's just that terminal side is laying right on the initial side. But in the Cartesian coordinate plane, we know that if one full rotation is 360 degrees, then half of that rotation, halfway around that circle, is going to be 180 degrees. So we're very comfortable with that measure. We know that half of that measure, or a quarter of 360 degrees, is going to give us a right angle measure, and so we're comfortable with 90 degrees. If we go 3/4 of the way around, we're going to have 270 degrees. But it's true that in every quadrant, in every piece of the Cartesian coordinate plane, there are some other common angle measures that are very interesting to us. You've probably heard of 30-degree angles, 45-degree angles, 60-degree angles. Those are very important in trigonometry. This is a big deal for us in trigonometry, and not only in this portion of the Cartesian coordinate plane, but the corresponding angles in every portion. This is 30 degrees from 90 degrees, and here's 45 degrees from 90 degrees, and here's 60 degrees from 90 degrees, and so on. 30 degrees from 180, 45 degrees from 180, 60 degrees from 180. All of these angle measures become extremely important to us. The ones in between all of those even measures that are 1/4, half, and 3/4 of the way around a full revolution in the circle. And here is 30 degrees from 270, and 45 degrees from 270, and 60 degrees from 270. So all of those angle measures are really, really important to us. Something else that's important to us when we start talking about trigonometry and where we are in the Cartesian coordinate plane is to talk about quadrants. Quadrants are a big deal for us. You may have been told this in geometry, I don't know, so I'm going to cover it here. There are 4 different quadrants in the Cartesian coordinate plane. They are counted going counterclockwise from 0 all the way through to 360. Everything here from 0 to 90 degrees is considered to be angle measure in the first quadrant. This is quadrant 1. Anything from 90 degrees to 180 degrees is quadrant 2. Anything from 180 degrees to 270 degrees lies in quadrant 3, and from 270 degrees back to our beginning, 360 degrees, is quadrant 4. So we count our quadrants starting between 0 and 90 degrees as quadrant 1, and then we go counterclockwise all the way around that Cartesian coordinate plane and count them 1, 2, 3, 4. The quadrants are important to us because of the different behavior of the signs, the positive and negative signs on our x and y coordinates. We use that. That's a big deal for us in trigonometry to figure out which quadrant we're in. So 50 degrees, which we know is between 0 and 90, is definitely in quadrant 1. 208 degrees, which is between 180 degrees and 270, is in quadrant 3, and negative 75 degrees right here is going to be in quadrant 4, right? Because a negative 90 degree angle would be all the way down here. This would be equivalent to having a negative 90 degree angle if we're at 270. So that's in between 0 degrees and negative 90 degrees. So we know that's in quadrant 4. So figuring out which quadrant we're in is going to become more and more important for us. So those angles, that 0 and 90 and 180 and 270 and 360, all of those are called quadrantal angles because they lie on the change in between our 4 quadrants. So we call them quadrantal angles. Not a big stretch. If we have 4 quadrants and those angles lie on the change in between those quadrants, it's not a big stretch for us to call them quadrantal angles. Here's a 90 degree angle, here's a 180 degree angle, here's a 270 degree angle, and here's a 360 degree angle. So those are quadrantal angles. Degree measure is something that we're really comfortable with, and so let's talk about coterminal angles. What does it mean for angles to be coterminal? Coterminal means that they share the same initial side and they share terminal sides. Here is angle alpha, that's a Greek letter, alpha, and here is angle beta, another Greek letter. You've probably seen theta. Theta is another common angle measure, another variable that we use quite often for angle measure. But here, alpha is a positive angle measure because it's counterclockwise, and beta is a corresponding negative angle measure. But here's their initial side, both lying on the positive x-axis, both have a vertex there at the origin, and here is their common terminal side. That's why they are coterminal. Alpha goes this many degrees, beta goes this many degrees in the opposite direction. So we have coterminal angles when they share a common terminal side, and they're definitely going to share a common initial side. So finding coterminal angles in degree measure, oop, things jumped around on me. Let's try this again. Finding coterminal angles in degree measure is going to look like this. We're going to have angle measures, and we're going to add or subtract multiples of 360 degrees. For example, this says find one positive and one negative angle measure that are coterminal with 112 degrees. Well, if it's going to be coterminal with 112 degrees, I can either add 360 to it to get the positive angle measure, or I can subtract 360 from it, and there's going to be my coterminal negative angle measure. So if you're asked to find coterminal angles with a given angle, then you just add a full revolution or subtract a full revolution. And for us in degree measure, that full revolution is 360 degrees. So let's do an example here. Find one positive and one negative angle that is coterminal with theta. Again, that just represents an angle measure, with theta equal 30 degrees. So I'm going to have a positive angle measure when I add one full revolution, which we know is 360 degrees. So 390 degrees is going to be the positive angle measure. We'll have a negative angle measure when I subtract one full revolution of 360 degrees. So that would be a negative 330 degrees. So there I have found one positive and one negative angle that are coterminal. I'm guaranteed they will share the terminal side with our angle measure of 30 degrees. So degree measure is something you're really comfortable with, not something that you're going to struggle with at all. We understand one full rotation in degree measure is definitely 360 degrees, but there's another way, a second way of measuring angles that's actually more specific. Remember, we had to talk about degrees and minutes and seconds to get a more specific, a more exact angle measure if that rotation was less than a full degree away from where we wanted to be. So a radian measure, and you don't need to know the definition of radians, I'm just giving it for those students that want to know what is a radian and why do we care. This is the actual definition of a radian. It's the measure of the central angle. Here for us it's theta. It's the measure of this angle that intercepts this arc S. And what is true about this arc S is that its measure along the surface of that circle is equal to the radius of each side of that angle. The radius of the circle that the angle lies within, with its central vertex point at the origin, if we measured this arc S, it would equal that radius measure. And it doesn't matter the size of R. It doesn't have to be this circle. That's true for any circle we want to go out here and draw in the plane. As long as this arc S is equivalent to the radius of that circle, then that measure is radian measure. The reason we want to use radian measure in higher mathematics is because it's real numbers. A radian is any real number. We don't have to worry about minutes and seconds when we're measuring with radian angle measure. So it's very specific, and we like it very, very much in upper level mathematics. So radians are something that we're going to use often and that you will eventually become comfortable with. You might not be right away, but you will become more comfortable with radians. So we know that one revolution in degrees is 360 degrees. The equivalent radian measure for one revolution is 2 pi. So if I'm in the plane and I measure a positive angle measure, one revolution in radians is 2 pi radians. So those are equivalent. 2 pi, 2 times 3.14 is roughly 6.28, so a little bit bigger than 6 in along the real number line. We'll talk more about other radian measures in the circle in the next video, so look for the next video.